In this video, I want to discuss the probability of at least one. So, at least one probabilities are fairly commonly tested in various ways on the ACT math exam. So before we get into the actual formula for the probability of at least one success, I want you to remember or keep in mind two things about probability. So first, the probability of any event occurring must be between 0 and 1, and that's inclusive. And this should be pretty obvious to you. So the probability of something happening at the lowest should be 0, which would mean it can't happen at all. We can't have negative probabilities. And at maximum, the probability should be 1, meaning that is the only outcome. And it can't have a probability greater than 1 because that would be greater than 100% probability, which again doesn't make any sense. Second, the probabilities of all possible outcomes must add up to 1. As an easy example, if you flip a coin and you get a heads, that's a 50% probability. And if you get a tails, that is a 50% probability. So if you flip a coin, when you add up the possibility of all possible outcomes, being a head or a tails, together those add up to a probability of 1, or 100%. Half for heads and a half for tails. So those are the two things to keep in mind when doing really any probability question, but more importantly, when doing the at least one probability questions. Okay, so let's define the formula for the probability of at least one. So we have that as the probability of at least one success is equal to 1 minus the probability of all failures. Let's do some examples. For our first example, we're going to roll 6 dice. What is the probability of getting at least one roll of 6? So we want the probability of at least 1 6, and that's going to be equal to 1 minus the probability of no 6s. So what is the probability of no 6s? Well, the probability if we were to roll 1 die would be 5 out of 6 that we don't get a single 6, because we can add up the probability of 1 plus the probability of 2 plus the probability of 3, 4, and 5, etc. So 5 6 would be the probability of not getting a single 6 in one roll. So using the multiplication rule for rolling 6 dice, that should just give us 5 6 to the 6th power. So 1 minus 5 6 to the 6th would be our answer. And that comes out to be approximately 0.665. Okay, on to example number 2. A student is given a 25-question math practice test. Let x represent the possible number of incorrect answers the student will make. For the first 6 possible values of x, the table provided gives the probability that this student will make x errors on the practice exam. Which of the following values is closest to the probability that the student will make at least one error on the exam? So for this can be a trick question. And I've seen examples of this on various ACT practice tests. But this is a trick question because the table there is misleading on purpose. So what we want to do is cut through the confusion and realize this is a really, really simple question if we approach it the right way. So the probability of making at least one error is the probability of making no errors and subtracting that from 1. So that will simply give us 1 minus 0.05. 0.05 being the probability of making 0 errors. So our answer here would be D, 95%. Now here's why this may be confusing. If this were a comprehensive table that showed that this student, that showed the rates of this student making errors for 6 through 25 as well, and all of the values added up to 100, we could simply take all of the individual errors, the percent or the probability of making 1 error, 2 errors, all the way through 25, and add all those up and get an answer. And that would equal, or it should equal if the table was done correctly, that should equal 1 minus the probability of no errors. So you'll actually see in the answers, there's a couple of misleading things. So 88% would be the probability, adding up the probabilities of all the items given. But again, that's not what we want. B is probably the most confusing of the answers, because if we add up the probability of 1 error, 2 errors, 3 errors, 4 errors, and 5 errors, that is actually going to give us 83%. And that's wrong because all of these total values doesn't add up to 1, so we're missing some data. C is the probability of making 1 error, not at least 1 error. D is the correct answer, and E, of course, cannot be determined from the given information, which, if you didn't know the simple formula, 1 minus the probability of no errors, then you may think this is true because we don't have all of the values for 6 errors through 25 errors.